This lecture is a continue of the gastrointestinal system. Our liver has several functions in the body. It helps to maintain blood glucose levels and glycogen stores important in carbohydrate metabolism. It will process triglycerides and cholesterol in lipid metabolism. It is also involved in protein metabolism because it converts the amine waste into urea to be excreted. Hormones and drugs are processed by the liver as well, forming bilirubin used in bile. Vitamin D is activated and stored by the liver. Other vitamins and minerals are stored in the liver, like vitamin A, vitamin B12, vitamin K, iron, and copper. It's also involved with the last step in activation of vitamin D. There are two phases of chemical reactions that take place to deal with toxins. In the phase 1 reactions, the original compound is converted to a toxic intermediate. This intermediate may actually be more harmful than the original compound, so it is critical that the phase 2 reactions occur quickly enough to handle the intermediates and avoid buildup. Slowed phase 2 reactions are associated with increased risk of skin, colon, breast, and prostate cancer. Phase 2 reactions involve several enzymes. There are about 100 enzymes in the P450 family alone, which is believed to be critical in cancer. Glutathione is another common example of a nutrient helpful to the liver. This can be found in fresh fruits and vegetables and whey protein isolates. This combines with selenium and vitamin E to make glutathione peroxidase and is also important in slowing the aging process. The large intestine, or colon, is used to absorb water and minerals. The contents of the colon should move through on a daily basis. There are 4 parts to the colon. The ascending colon travels upward on the right side of the abdomen. The transverse colon moves across from right to left across the superior portion, and the descending colon moves towards the bottom on the left side. The distal part of the colon is curved and is called the sigmoid colon. Fiber is important for forming bulk in the colon and feces, and to scrub the walls of the colon. It is beneficial in reducing cardiac risk since it helps to bind and remove excess bile and cholesterol. It helps to increase the speed things move through the colon, as well as absorbing excess water in the stools to balance things out. Although it is recommended we consume 25 to 30 grams of fiber daily, in this country we tend to only average 10 to 15 grams of fiber per day. Bacteria are present in very high numbers in the colon and are important in assisting in the digestive process. Just over half the vitamin K we receive is produced by bacteria in our gut. The rectum is a pouch at the distal end of the digestive tract used to store waste products until the body is able to excrete them. The anus is the external opening to the digestive system. This tube also has an internal and external sphincter muscle. The internal sphincter is under involuntary control, while the external sphincter is under voluntary control. This animation is a short summary of the digestive process by McGraw-Hill.
The primary functions of the digestive system are the breakdown of food, called digestion, and absorption of nutrients. Digestion begins in the mouth, where the teeth break food into smaller particles during mastication. Salivary glands located near the oral cavity secrete saliva, which begins chemical digestion and keeps the food moist. As food is swallowed, the soft palate blocks the upper pharynx to prevent food from entering the nasal cavity, and multiple voluntary muscles in the face, neck, and tongue contract, pushing food particles through the pharynx. The food passes over the epiglottis, which prevents food entry into the respiratory system, and then into the esophagus, which connects the pharynx to the stomach. The one-way movement of the food mass, now called a bolus, is controlled by wave-like involuntary muscle contractions. This movement is known as peristalsis. The bolus now enters the stomach. Folds in the stomach wall, called rugae, allow for expansion as the stomach fills. Stomach cells secrete hydrochloric acid, pepsinogen, and various regulatory hormones that chemically digest the bolus. Muscular contractions in the stomach churn its contents to further break down the bolus and mix it with stomach secretions to form a thick liquid called chyme. Chyme exits the stomach through the pyloric sphincter and enters the small intestine, the major site of nutrient absorption. The small intestine consists of three parts: the duodenum, jejunum, and ileum. Bile from the liver and digestive enzymes from the pancreas empty into the duodenum to aid in digestion. Absorbed nutrients pass from the lumen of the small intestine into blood and lymph. Chyme not absorbed in the small intestine enters the large intestine. As it passes through the cecum and ascending, transverse, descending, and sigmoid colon, water and salts are absorbed and chyme is converted into feces. The rectum stores feces until nervous stimulation initiates the defecation reflex, resulting in elimination through the anal canal.
Different nutrients are absorbed in different places. The small and medium fats, which are produced by bacteria, are absorbed into the bloodstream in the small intestine. They will go through the hepatic portal circulation in the bloodstream. The carbohydrates and proteins are also absorbed into the bloodstream and travel via the hepatic portal circulation. The large fats, which are acquired through the diet, go into the lacteals. This allows them to bypass the hepatic circulation and join the lymph, where they will enter the bloodstream right near the heart. This gives the body the opportunity to store these fats prior to the liver processing them. Water and minerals are absorbed in the colon. The chylomicron is the large form of fat formed in the small intestine and transports lipids to the adipose tissue. The VLDL, or very low density lipoprotein, is made in the liver. This transports triglycerides to the adipose tissue, where it will deposit some lipid, becoming more dense, and then become an LDL, or low density lipoprotein. The LDL is about 75% of the total cholesterol. It is taken to the cells to do repair and is also used for forming steroids and bile. The HDL, or high-density lipoprotein, contains the least fat and is used to remove the excess cholesterol from the liver for elimination. The ratio of cholesterol levels is associated with cardiac risk. The ratio of total cholesterol to HDL should be less than 4. Anything over 4 is considered elevated risk for cardiovascular disease.